Hello guys, I'm Harsh Yadav and today I'll be showcasing my letter recognition system project to you, and I'll be also telling you that how to run it in your local machine and how to clone the project from the GitHub and all the requirements that you need to satisfy for the project. Okay, so let's get started. So this is the repository for the letter classification project, and it has a license. This is the MIT license, and then we'll go through the README, and this is the code. This is the actual CNN model .h5, and .h5 is the extension with which we store the models, and this is the actual code, MNIST letter code, and this is actually a Jupyter file, and this has all the code for the CNN model. And MNIST letter GUI is actually a small GUI where you can try out making the letters, and then it will give the prediction, and it will use the CNN model to give the prediction. So first of all, I'll tell you how to set it up on your machine and how to do the things. So first of all, we'll go to code and then we'll download the zip. So the zip should be downloaded in some time. So actually, I have already downloaded the zip, and this is the thing which we get after we like after we open the zip. So this is the letter classifier, and it will not have the this checkpoints. So it will have only this thing. So first of all, we'll go to MNIST letter code. This is a Jupyter file. So I have already opened it. This is the actual Jupyter file which you will get after opening it. And if you don't want to run it in Jupyter, then you can also run it in Kaggle. You'll get the Kaggle link in my README. This is the Kaggle link. You can try it out in Kaggle also. So we'll just open this one also. And this is the actual code that you can also try it out in Kaggle. And I have already explained everything in the code in the Kaggle file also, and in the this file also, like Jupyter file also. uh, Wait a second. Yes. So first of all, we'll import the libraries, and these are the libraries that you have to download in your system. Without these libraries, you will not be able to run it. And these are common libraries like TensorFlow and sklearn and Matplotlib and NumPy. So I think it should be downloaded by now. By now, this will not be there. This is the file which is created when we open the Jupyter notebook. So this will not be with the project. So this will be created itself by the system. So you don't need to worry about that. So this letter classifier main, this is the actual project. So if we unzip it, then we get this, and this is the actual project. But we also need to put the input in this project. So if you want to download the input, the MNIST letter input, then you will have to go to my Google Drive, and then you will have to download it, or otherwise you can download it from anywhere also in the internet. So like it's written, to run this project locally on system, you will have to download the input for the model from the Google Drive. So if you go to the Google Drive link, you can easily just go here, and you can download it like from this input file. You can download everything, and then you can just extract it, and after extracting it, you will get this input right here. This is the file that I downloaded from Google Drive, and this is the input data extracted. And now I'll have to put this input in the letter classifier, and now your project is ready to run. You can just click on the MNIST letter code, and then you can run the Jupyter file. And after running the Jupyter file, you will get this best CNN model. This is the file which can get updated time to time as you run the code, and this will store only the best CNN model that trains on the project. So I guess I have told you how to run it on a system. Now I'll just go through the actual project. So before going through the actual project, we'll read the README file. So this is the thing that I have told you. Like, you'll have to download the dataset. Without a dataset, you can't run the model. You can't run the Jupyter file. You will need the dataset. And then this is the MList letter classifier. So we'll just classify the letters, like capital letters essentially, and we'll use the MNIST dataset. This is a very famous dataset, and everybody uses this dataset to train their models. And some people use other dataset also, but this dataset is like a standard dataset. This, if you are like making a letter recognition system, then I'll recommend you to use the MNIST dataset. It is pretty good. and it has 88,000 training data sets and 144, 14,000 testing data sets, essentially images. So we have done pre-processing of the data also, and we have used multiple models, and then the GUI part, and then these are the requirements. And if you want to install the requirements, then you can just copy this and run it in your CMD. And if you want to clone it, then you can clone it from here. And essentially, this is all that you need to know. So now I'll go through my project. So this is just we are importing the libraries here. So I guess I should just run through the Kaggle one of it, because I don't have a GPU and I'll need a GPU to run it. So let's go to the Kaggle one. This code which will load in Kaggle and this code which is in MNIST letter code, they both are the same. Like this is just the Jupyter file and this is the Kaggle file. This is the Kaggle notebook. And before running the Kaggle notebook, I recommend you, like, you should do this thing. You should go to here, session options. You'll get it. Here is the dataset, MNIST dataset. It is freely available in Kaggle also, and this is the output directory. You will get the model here after you run the notebook. And then this is the accelerator. This accelerator is very important to run the notebook, because if you don't run the notebook with accelerator, then it will take hours to run the notebook. So either you can take the GPU T402 or you can take the GPU P100. GPU P100 is a little bit faster, but it is unstable. So it depends on you which one you want to use. So these are the what do you tell, they're the libraries. And then now we, and this is the cell which will tell you if GP is detected or not. So you can run this and then it will tell you if the GP is detected or not. Or this is the way of finding out if you actually did turn on the accelerator, or if you locally have a GPU in your system. And this is the line for loading and inspecting the data, the training data. And Kaggle input, this is the directory which we'll use, because this is the input thing, and we are running it on Kaggle. And MNIST is the dataset, and then MNIST balanced mapping. So we'll use this MNIST balanced train and testing and mapping. The other ones we will not use, because the best ones to use are the MNIST balanced ones. And there is a problem in MNIST letters, because it has only 19 classes and testing data. So that's why we'll not use it. The MNIST balanced is quite better than that. And okay, then we'll have to go to the dictionary, because we'll have to create a dictionary, because you will know it. You'll know it in a second. Because we'll have to map it with A, and A has to take the zero with it, and B has to take one with it, because you can't directly map it to A. and and MNIST dataset has this feature of this dictionary. This uh, has the feature of this yeah, so has the feature of this balanced mapping. So mapping is essentially used for mapping A to zero, uh, and other letters also to the respective things. So you will see this like this. So 0 will be mapped to A, and 25 will be mapped to Z. So when the model predicts 25, then we will know that the model has actually predicted Z, not 25, because 25 is mapped to Z. And one more thing about these datasets is that we have to filter and pre-process our training data also, because without filtering and pre-processing a training data, the model can't be trained in a good way. We always want our values to be between -1 to 1, because that's the way models are able to catch the values pretty nicely. And in our data set, the models, the values are between 0 to 55, because that are the pixel intensity values. So they are between 0 to 256, to 0 to 255. Like there are 256 values, so we'll just divide it by 256, and then it will become 0 to 1. And we will do it after some time, but this is the thing that we essentially do. So we'll just make a training data frame, and we have made train df. So we already made the train df here, like train df. we just read the CSV through pandas, and then essentially we looked at it head, and this is the head, and then we describe the data. The describe will tell the median, mode, and maximum of the data, and then we'll also know the shape of the data. This is the shape. It has 1 lakh and 12,800 examples, and 785 is because we get it after we do 28 into 28. I'm sorry, 28 into 28. Yeah, so 784 values get we get after that, and one value is for the class which it belongs to. So 784 plus 1. And why we use 28 is because the images are of pixel 28 and 28. We just make it into a one dimensional array. So after this is the balanced mapping. I have told you about this, and we just make a new training data frame because we only want 10 to 36. 10 is for the capital A, and 36 is for capital Z, and 0 to 10 were for 0 to 9, like digits. But it also had the digits in this balanced data set, but we removed them because we don't want them. They create confusion. There is a lot of confusion between 1 and I, 1 and L, and there is a confusion between 0 and O. So we don't want that confusion, so we'll just take the 10 to 36, and we'll just go through it. And this is the data frame new, and train data frame new, and we'll just make it, and we'll just put the values. Train data frame minus 10 because we started from 10. So these are the things that you will get to know if you run the file, the notebook. And after we removed them, we were only left with 624,000 images. Essentially, before that we had somewhat about 1 lakh images. So now we'll take a sample image from our dataset, and this is a sample image, and this is like the shape of the image, and this is the sample label associated with it. So 5, what is 5? 5 essentially stands for F, because we have done it right here, right? 5 stands for F. So this tells us that the image we have represents F. So we'll go ahead, and these are the functions that we'll use for rotating the images. Why will we rotate? You will get to know after we run these cells. And this was the image. This is the image of F. You will not be able to recognize it right now, I know, but when we rotate it and do the mirror image of it, then we'll get F. And why is the data like this? Because the data is like this in the MNIST dataset. It's the thing with MNIST dataset that it has rotated images and mirror imaged images. So to convert them to human interpretable images, we have to rotate them and like do the things. So this is the F. Now you will be able to recognize F. So we'll do this to every image. We did that to only the image 1000. It was a sample image. Now we'll do this to every image. So like here we did it to every image. We applied it along axis, and the dimension is the function that we are giving it to. Giving it. This is the function def dimension. And now we'll go ahead. And these are some sample images. These were the images before rotation, and now these are the images after rotation. Yes, these are the images after rotation. And now we also want the testing data, because we only loaded the training data. We'll load the testing data, we'll find out the head, we'll do the describe, and then we'll filter the testing data because we only want A to 20, A to Z. So we'll put 10 and 36 there. So it will like filter the data. And from here we are separating our X test and Y test. X test is everything instead of the zeroth column, because in the zeroth column we have the like the label. So if it's 0 it's A, if it's 5 it's F. So zeroth column is the label, that's the Y test. And X test is are the other features, 784 features. So we'll go ahead. This is the shape of X test, and we'll go ahead. And these are the sample training, these are the sample testing images after rotation. So we'll just compare the training and testing sample sizes. This is the train and this is the test. We'll just normalize the data. I told you we'll divide by 255 just to normalize and to keep it between 0 and 1. And this will plot the number of classes. So we have 26 letters in English alphabets, and we have 26 classes for the English alphabets. And now we'll reshape the data for the models. Why are we reshaping this data for the models? Because this one x train CNN, we printed the x CNN shape. So this is the shape of the x CNN that the CNN model takes, because CNN model only takes four dimensional input. So this is the number of images. This is the two dimensional representation of the image. And for one, we are using one because we are only passing it black and white images, and it can take many values, 1 2 3. So that just tells if the image is black and white or it is like colored image or something else. So we'll go ahead, we'll visualize the distribution. So we have 2400 like images of A, and every letter has 2400 images. And for testing data set also we have 400 images. So it's a 6:1 ratio. And now the real game begins. Now we start to define the models. So we'll define a training and neural network model. So these cells will take a lot of time to run. Neural network is estimated to run about 2 minutes. I wrote all these comments after running these. And then we have estimate time for decision model also as 1 minute, and training evaluator random forests. So in the Kaggle file, I have not run all these models. So we'll go to the Jupyter file, because here I have already run all the models. So from here I can tell you properly. Wait a second. Yeah, okay. So from here I can tell you properly uh, what the models are and what their outputs are. So we'll go there. So we were right here. We were on neural networks. So neural network, we'll just define three layers. It is not the main model that we will use. The main model is CNN. These models are just to tell like why the neural network is not as good as CNN in image classification examples, and why like the decision tree is not as good, why the random forest is not as good, why the XGBoost is not as good. These are the models which are usually used by people for machine learning competitions also, and many other things also. But CNN model is the best model, and this is the actual model, CNN model. So let's head back to neural networks. This is the neural network model. So first of all, we'll just define it using Keras. Keras is available through TensorFlow, so it just makes our work easier. And then we'll just compile it. We'll provide the optimizer as Adam optimizer is just it just optimizes the gradient descent. Gradient descent is essentially used for training the model for like adjusting its weights and biases. So Adam just helps us in training the model a little bit faster. And sparse categorical cross entropy, we use it when we have different labels in our actual classification. If we have 0 and 1, then we only use categorical cross entropy. And matrix is the accuracy. All obviously we only want the accuracy to be good, so we'll just set the metric to accuracy. And batch sizes, you can fiddle with the batch sizes. I'll suggest it to keep it 32. If you have a very powerful GPU, then I'll suggest it go for 256 or maybe 512. Don't go above that. And epochs is the number of turns that it will take to fit. So this is everything. So here the model started and it fitted it, and it got an validation accuracy. Validation accuracy is the actual accuracy that we should think of. Like the testing data accuracy is 95%, but it's not what we use. Validation accuracy is the actual accuracy, because that's the accuracy that we get on the new data that we pass it to the model. So this is the accuracy 90%, which is pretty good actually, but we can do better than that. And this is the neural network accuracy plot. So I have a little bit less time, so I'll just run through all these. And this is the loss. And we then defined the decision model. Decision tree model just got 72% accuracy, and then random forest just got 88%. And then we have the XGBoost, and it got 86%. Then this is the final model. This is the best model. This is the actual model that we use, and this is the main thing. This is the main gist of this project. CNN model. So CNN model has convolutional layers. Convolutional layers is basically used for finding out the edges of the images for learning patterns better. So we'll add three convolution blocks, because that is the main thing that we need to do with the model. like learning edges, learning patterns of the images. And then there's the residual connection layer. We use this for like better uh, better training accuracies. And then this is the final connected layer. This is the main layer that every neural network has. This is the same thing that we talked about in neural networks. This is the same dense layer 400. We use the activation as ReLU. This is the rectified linear unit, and this is the best activation function to use in this type of problems. And this is the regularization that we are using to reduce overfitting. And softmax is used when we have a lot of classes to predict. If we don't have a lot of classes to predict, then we just use um, sigmoid function. Okay, so we'll just go ahead. This is the actual architecture, and boom, this is the final fitting step. So we'll use the batch size 512 because I trained it on Kaggle and we had the GPU on Kaggle. So we just use 512 and we use 40 epochs because that's the good number of epochs that I found out after fiddling with it. So after the 40 epochs, we get a very good accuracy of 95.41%, and it sometimes reaches 96% also. Like here, right here, it reached 96%. So Keras just saved it. These warnings are that the file is being saved. And right here, we got the 96% accuracy. Then we'll just plot the accuracy. This is the accuracy curve, this is the loss curve, and this is the comparison of the models. Like this is not some real code to explain this, everybody will know. There's the confusion matrix, like which we classified good and which one classified bad. And this was a true label on the left hand side and predicted label for the y-axis. And you will see the difference. You will see the difference. Look at the CNN accuracy. It has literally zeros everywhere. That means it has predicted everything good. But right here there was some problems because I, this was for I, this was for L. That means that it predicted labels which were L, it predicted it as I. And L and I have a lot of similarity in writing in English language, so that's why there was a little bit less accuracy in this. If we removed it, then we might have got 99% accuracy also. And so this is a pretty good thing. And then this is the class wise accuracy for random forests, for decision trees, for XGBoost, this for neural networks, and this is for CNN. CNN is like on top. It's like 100% accuracy if we remove I, L. Okay, so these are the misclassified examples. So this, I know you won't also be able to classify these properly. So how can we expect our neural network to classify it properly? So the true label for this one, this image, this was L. The true label was L, and CNN classified as it as I. And if and even if I would have classified it, I would have also given it I. So you can't like get 100% accuracy. Most of the models get 90%, 93%, 95 is pretty good. You should be satisfied with it. And these are the things that we classified correctly. And this is the feature importance. This is actually like you can read it from here. You can read it, you will get to know it. Okay, so this was the actual code, and I'll show you the line from where we are saving the model. We are saving the model from the CNN epoch line. Let me show it to you real fast. Okay, so this is it. Model checkpoint best CNN model, and then we'll monitor the validation accuracy. And when the accuracy is the best, then we'll just save it. This is the line when we save the model. Okay, so we have just 7 minutes remaining. Okay, we'll just go through the GUI now. And readme is just the readme, you know that. And this was the model that we saved. And if you run it, and then it will save another model. So it might get like less accuracy if you don't run it to 40 epochs. I'll recommend you to run it to 40 epochs only. After you run it to 40 epochs, then only you should go to the GUI. So we'll go to the GUI right now. This is the GUI. You can just, this is just a Python script. We are using tkinter here, and also TTK bootstrap libraries. Tkinter is essentially, it comes with Python. There is nothing big in it, and the simple code. We just wrote a function here for immunist classifier GUI, and we just define the init. Init is like the basic function that we have to define in GUIs. And Then we just start drawing, we just add this canvas, and then we just add the draw function after, like, when we add the draw function, then we have to give it to other functions, like create line function also. So basically this is it. Let me just run the GUI for you, and then you can also try out the GUI after downloading my project from GitHub, and I'll show you real quick how it works. So it is loading the GUI. It will take about 20 seconds to load it because the model is quite large. It's about 17 MBs. Wait a second, wait a second. Error message, no such directory found. Wait a second. This H5. I think we hit a roadblock. Just give me a second, I'll make it right. Just give me a second. Sorry for the interruption. I think it should work now. The like path for the model was a little bit different when I downloaded it. Yes, so this is the GUI. So we have a canvas here. We can draw the letters. We can see the predictions also, and then we just get the results. Also, we can change the themes also. Like if you want white theme, you can go to flatly. You can go darkly also. Darkly is a little bit. I prefer Cyborg, to be honest. Superhero is also pretty good, but we'll just go with Cyborg. So let me just give you like this is A, so we'll predict it, and the prediction is 99.8%. Like it's A. So let's clear the canvas, and let's go for some hard letters. Let's go for B. B is pretty hard to classify, so we'll just go for B, and it's 99.42. Okay, so we'll just clear the canvas. Okay, G is like the hardest of them all. So we'll just go with G. Let's see what it classifies. G 99.41%, it's G. Okay, fine. Let's go with I. It sometimes classifies I as L, obviously. Like this, you will see this. Prediction is L this percent, and I also it gets it. Because there is a intrinsic problem with I and L, so the model can't do much in that. Okay, so we'll go for L now. Let's go. Okay, 97% L. It's pretty nice, this one. And let's go for O here. Let's predict it. It's O. Okay, so I think you got the gist of it. Now we'll just go to the model info. You can check out the model info from here. And this is it. This is the whole project. And I hope you liked my project. And thank you for being with me. Have a nice day.